Today we're going to talk about graphing piecewise functions without the use of a calculator. So here we have a piecewise function defined as two pieces. F of x equals x plus 5 when x is less than negative 3, and f of x equals negative x plus 2 when x is greater than or equal to negative 3. So first thing we're going to do is figure out what kinds of circles are we going to use. So if we're including a value, so like this one right here, greater than or equal to, that's going to indicate to us a closed circle on a graph. If we don't include a value, so like this right here, less than, that means we're not going to fill that in. We're going to leave that as an open circle on a graph. So what ends up happening here is we have two linear pieces of a function. And these two pieces will be graphed separately. But our strategy is going to be effectively the same thing. What we want to do are figure out values at either end of the piece and then connect those together to create our line segment, and then do the same thing for the other piece. So really the value that seems to be of interest to us is at negative 3. The first function, we're going to define it for certain values that are less than negative 3. So starting all the way on our grid anyway from negative 10 and then all the way up to negative 3. So what I want to do first is I want to figure out what is the value at negative 3. So I'm going to plug negative 3 into here. Now again, I know it's not actually being plugged into the function and said this is the value because it's got that open circle. But we are going to use that value as a reference. So f of negative 3, I'm going to take negative 3 and plug it into here, and I'll end up getting negative 3 plus 5, which is 2. So on my graph, I'm going to put an open circle at negative 3 and 2. So I'm going to label these open and closed, just so I know that there's a difference between the two. Now, great, I've got a point, but that does not give me a line. So I need a little bit more information, and then what I'm going to need to do is figure out what this graph does. Now, normally if we're given a line in slope-intercept form, we would graph the intercept and then use the slope. I think that might be a little bit more challenging here because sometimes we want to work backwards, and it's much easier if we just pick another value, in my opinion anyway, and then plug that in. So I might find f of negative 10 because that's all the way to the far left of that window. So negative 10 plugged in here plus 5 gives me negative 5. So my point is at negative 10x and negative 5, there we go. And because that graph is going to effectively continue afterwards, I'm going to leave that as a closed circle and connect those two pieces, and I did a pretty good job there. All right, so my next part is to graph the second piece, which is negative x plus 2. Now I know at negative 3 it's going to switch functions from that top piece to that bottom piece. But I'm still going to use negative 3 as a reference. I'm going to plug negative 3 into there. So the opposite of negative 3 plus 2 would give me 5. So when I go to negative 3, 5, here I'm actually going to fill that circle in because of that equal sign. I know that's a closed circle. So again, I've got one point as a reference, but I need another one to complete my line segment. So I'm going to go to the far right and plug in positive 10. So plugging in positive 10, the opposite of 10 is negative 10, and I add 2, that's going to give me negative 8. So I've got a point at 10 comma negative 8, and I'm off a little bit, but you get the general idea of where the segment is supposed to go. Obviously on your paper you'd use a straight edge, but on a computer screen it's a little bit more difficult to do. All right, what happens when we have three pieces? I don't know, let's see. So we've got function h of x equals negative 1/2 x plus 3 when x is less than or equal to negative 2. It's equal to x when x is between negative 2 and 2, not inclusive. And it's equal to 1/2 x plus 1 when x is greater than 2. First thing I want to do is label these things. I know that at negative 2, I'm going to have a closed circle. On the second part, though, I'm going to have an open circle here, and an open circle here because I don't see that equal sign. Our strategy is still going to be the same, and actually that middle piece is going to be a little bit easier for us because we're given the left and the right bounds already. So for this first one, when I have f of x, or h of x, sorry, equals negative 1/2 x plus 3, I know that I want the value at negative 2, so I'm going to plug that in first. So the negative 1/2 times negative 2 would give me positive 1, and I add 3, that's going to give me 4. So again, it's a closed circle. I'm going to fill that in. I need another point to help me reference, so I'm going to go with negative 10 again because that's my far end. And the reality is I can pick any points in between, but I'm picking negative 10 because I want to know what that end value is going to be. Negative 10 times negative 1/2 will give me 5, plus 3 gives me 8. So I've got a point at negative 10, 8. And again, I'm going to connect those two pieces, and so that's the first piece that's been graphed. Now I want the second one. The second one is the equation h of x equals x. That's going to be a really easy one for us to do. When I plug in the values, I'm going to take the ones on the far left and the far right, which are clearly told to us. So f of negative 2 is negative 2, and this is going to be that open circle because I don't have that equal sign. And do the same thing for 2, gives me 2. And connect those, and that's my second piece. And then I graph my third one. 1/2 x plus 1. So I'm starting at the value of 2. Again, an open circle. No equal sign underneath. Half of 1 is 1. Add 1, you get 2. So it's still going to be an open circle there. And it just overlaps. It's not a big deal. And sometimes what happens is that value will actually fill it in, which is not a big deal at all for us. Then we're going to find the far right value, which would be at 10. So half of 10 is 5. Add 1, you get 6. And that, we don't worry about open versus closed here because that's the end of that graph. And so it's going to look something like that. And so that's our piecewise function with 3. And we could even take it a step further and do one with 4. I really like this one because of something that happens at the very end as well. It's something that's going to happen in the middle that might throw us for a little bit of a loop. So let's stand up to the challenge. All right, n of x, we've got it defined in 4 pieces. 1/2 x plus 4, when x is less than or equal to negative 6. We've got it as negative 2x between negative 4 and 2. We have it as 5 between 4 and 7, and equal to 6 when x is greater than or equal to 7. So again, my first step, I'm going to label these guys as open or closed, so I know when I'm evaluating what kind of circles I'm going to use. And now I want to look at each piece individually. So I'm going to start with the top piece. I know I want to plug in negative 6 because they effectively tell me to do that. Take 1/2 of negative 6, that's negative 3, plus 4 is 1. So at negative 6, I have a point at 1. And I'm filleting in because of the equal sign. And again, I want to really know what's going on to the left of that. So I'm going to go all the way to negative 10. That gives me negative 5 plus 4, which is negative 1. So at negative 10, I'm at negative 1, and my first piece has been graphed. Second piece is h or n of x equals negative 2x. So I'm going to plug in negative 4. My leftmost point, I'm going to do a better job of writing a 4. I'm sorry about that. I think I was writing a 1 or something. Negative 4 times negative 2x gives me 8. And it's an open circle, no equal sign. So open at that value. And then f of 2, take negative 2 times 2, that's negative 4. So at 2, we have a point at negative 4, and I'm going to fill that one in because of the equal sign. So there's that second piece. And I love the third and fourth piece because they look really complicated, but they're so awesome to graph. So what I'm looking at here is from 4 to 7, I'm going to have a value of 5. In other words, it's a constant value. It's always going to equal 5. So if I were to find, and I'm writing f, but I should be writing n of 4, and we know it's going to equal 5 because it says it's 5. It's always 5. And if I did n of 7, it's the same thing. It's 5. Again, I'm using these as a reference to graph that second piece. At 4, comma 5, I'm going to put a closed circle. And at 7, comma 5, I'm going to put an open circle. And there's that piece. And my next piece is that last one that says 6. So when x is greater than or equal to 7, it's going to equal 6. Well, what that tells me is that my function's always 6 once I get to the value of 7, and I'm going to fill that in. It never stops. It's going to stay flat and have that value there. And what we have is a part of what's called a step function, where it's going to step up or step down immediately when you get there, and each piece is a constant function. But again, the main idea is to figure out which function am I plugging in and what values do I want to plug in there. And if I can figure out the open versus closed circle, then at this point when we're dealing with the linear functions, it's just a matter of making line segments using those points. So we want to evaluate correctly and then make sure we use the correct type of circles.